These slides focus on the second part of study unit 7. So it looks at section 15.4 in the textbook on page 360. If you look at the outcomes in the study guide, you should be able to understand the 3 assumptions that are necessary for the F statistic to follow F distribution. So I already mentioned these assumptions in part 1. Then you should also be able to calculate the F statistic, or if it's given on the output, you can simply determine it from there. And then you should be able to interpret and determine the p-value from the computer output as well. And then lastly, test the hypothesis in a one-way ANOVA. Usually I don't specify whether you have to use the F-test or the p-value approach, but I discuss both of these in the slides. There are 3 assumptions in ANOVA that you should take note of. Firstly, the observations should be independent. This means that your experiment should be totally random, so samples should be randomly drawn from the population, and your treatments or groups should then be assigned randomly to the different objects or people in your study. Then secondly, data needs to be taken from a normally distributed population. If we are working with large samples, remember, meaning sample sizes of 30 or greater, it's no problem, because under the central limit theorem we can assume normality since our samples are large, and we studied this in chapter 8. But if your samples are small, then we need to check this assumption using the normal probability plot on the computer output, but we will look at this in class in part 3. Then the last assumption is the homogeneity of variances. There we check whether the variance of the data within each group is the same. So they need to be statistically equal, and we can check that from the residual plot on the computer output as well. Then if any of these assumptions are violated, it means that your F statistic does not follow F distribution, and your inferences or your conclusions that you draw from your hypothesis test might not be reliable then. Like I mentioned in the outcomes, there's 2 ways of performing the hypothesis test. You can either do the F-test or the p-value approach. The F-test is also known as the critical value approach. So in step 1 of the F-test, we state the hypotheses like I showed you in part 1. In the null hypothesis, we state that all the population means is going to be the same, and in the alternative hypothesis, we state a sentence which indicates that not all the population means are equal or the same, or at least one of the population means will be different. Then in step 2, we determine the F statistic. So either you can read that off from the computer output in your ANOVA table if it's given, or if that was one of the missing values on your output, then you need to calculate that. Then in step 3, you make your comparison and draw your conclusion. So you compare your F statistic in step 2 to your F critical value from your F table. Now your degrees of freedom that you use, this was indicated in your ANOVA table in part 1. Your V1 is G minus 1, and that was your treatment degrees of freedom, and that will give you your column in your F table, and your V2 is your in total minus G, and as indicated in part 1, that represented your error degrees of freedom. And then remember from chapter 14 that we have a 1% and a 5% F table, but I will state in the exercises or in a test or exam whether you should test the hypothesis at a 1% or at a 5%. Then you can compare your F statistic and your F critical value, and the decision rules that we use is indicated over here. If your F statistic is greater than or equal to your F critical value, then your null hypothesis will be rejected. So if this is rejected, it means that your population means will not be the same. Or you can say that they will differ statistically. But if your F statistic is less than your F critical value from your F table, then your null hypothesis will not be rejected. So it means that this is true. So then your population means will be the same, or statistically they will not differ from each other. Before we look at the hypothesis test for example 15.1, I also included the graphical representation of the means and the data from example 15.1, and this is provided in figure 15.1 in the textbook. So you can see visually then in this graph if there's going to be a variation between your population means or not, which we basically want to test in the hypothesis test. Remember, we are busy with statistical inference, so we use the sample data, meaning that the data for the 20 students, to draw conclusions in our hypothesis test for the population means. So if you look at the sample data, first of all, on the x-axis, you have your different groups. So we have the 4 teaching styles on the x-axis, and then what we observed was the student test scores or the marks, and that will be on your y-axis. Then we have a scatter plot for each group for the different values that the students obtained within the 4 groups. And then these lines indicate your group means for the different groups. So if you look at the scatter plot, you can see that there's definitely a difference between the means for the 4 groups, because there is some variation between them. And group 1 will have the highest scores, whereas group 4 had the lowest scores. And then this grey line over here indicates your overall mean for all 20 students. On your ANOVA computer output, you can see that your F statistic is going to be 27.7354, and that will be the value that we use in our hypothesis test for the F test. So for step 1 of the F test, for example 15.1, you state your hypotheses. So for the null hypothesis, we will state that μ1 is equal to μ2 is equal to μ3 is equal to μ4, because we had 4 different groups. And then in the alternative hypothesis, not all our population means are equal. Then in step 2, you write down your F statistic, which we read off from our ANOVA computer output. And let's say we test the hypothesis at a 1% significance level. Then you go to your 0.01 F table, and our treatment degrees of freedom was 3, and our error degrees of freedom was 16. So if you go to column 3, row 16 in the 1% F table, then you will see that your F critical value is 5.29. If we compare this value to our F statistic in step 2, we can see that our F statistic will be greater than our F critical value, so we can reject our null hypothesis according to our decision rule. So that means that the population mean test scores are statistically not the same for the four teaching styles, which implies that some of the teaching styles work better than the others. And you could also see this from the graph. So please always go back to the context of the problem in drawing your conclusion, just like we did in chapter 11. You can now practice the F-test, please, for exercise 1 on part 2, and you can compare your answers to the solutions on eFundi. The next section looks at the p-value approach to performing the hypothesis test. So in step 1, we also state the hypothesis as we did in the F-test. So it's stated in exactly the same way. And in step 2 and 3, we make the comparison and draw the conclusion. So first of all, you need to obtain the p-value from the computer output in your ANOVA table. And then you compare this p-value to your significance level. Then for your decision rule, the same as in chapter 11, if your p-value is less than or equal to your significance level, then the null hypothesis will be rejected. So it means that the null hypothesis will not be true. So the population means will differ from each other, or statistically they will not be the same. But if your p-value from your computer output is greater than your significance level, then your null hypothesis will not be rejected. So it means that it will be true. So the population means will be the same, or statistically they will not differ. If the p-value is not given on the computer output, then we can estimate that from the F tables, but since we only have the 1% and the 5% F table, our range of values will be very limited, but you can read through that section in the textbook since it's not part of the outcomes, so you will not be tested on that in a test or exam. On the computer output, you will find your p-value here in the last column in your ANOVA table. So if we look at example 15.1, you state your null and alternative hypothesis, and then for step 2, you write down that p-value and you give your significance level. So let's say we tested the hypothesis at a 1% significance level, then your alpha will be 0.01. If we compare that p-value to your significance level in step 2, then we can see that our p-value will definitely be less than our significance level. So we can reject the null hypothesis. So you will be able to draw the same conclusion as we did in the F-test. You can now try the hypothesis test with the p-value approach, please. And again, the answers have been uploaded on eFundi. And this is then the end of part 2.